Ayubon, everyone, and a very warm welcome to Study Hub Sri Lanka. Today, we're jumping right into Unit 1 of your AL Physics syllabus. We're going to talk about the essential tools that make all of modern science possible. Yep, precision measuring instruments. Let's get started with the core instruments you'll be using in the lab.
So, let me ask you something. Have you ever tried to measure something really tiny with your normal school ruler? You know, like the thickness of a single piece of paper? You realize pretty fast it's not going to work, right? For A-level physics, we need to be much more precise than that. And this slide, it shows the problem perfectly. On the left, with our standard ruler, the measurement is somewhere between the millimeter marks. We're forced to guess. But look at the right. Those incredibly fine lines, that's what precision instruments give us. This is the difference between just an estimate and a real, proper measurement.
So what's the secret? How do these tools work? Well, it all comes down to a single, super important idea called the least count, or LC for short. It's simply the smallest, tiniest value that an instrument can accurately measure. Your meter ruler? Its LC is 1 millimeter. But a vernier caliper is 10 times more precise, down to 0.1 millimeters. And the micrometer? An incredible 100 times more precise, at 0.01 millimeters.
Okay, let's meet our first precision tool. This one is a real workhorse in the lab, and you'll be using it all the time. The versatile vernier caliper.
Let's do a quick tour of the parts. You've got the big external jaws here for measuring outer diameters, and these smaller internal jaws up top for inner diameters. And see this thin bar that slides out the end? That's the depth bar. But the real magic, the clever part, is how this sliding vernier scale works together with the fixed main scale.
So, how does it achieve this cool trick? It's all about the clever relationship between the two scales. As you can see, 10 little divisions on the sliding vernier scale line up perfectly with 9 divisions on the main scale. So that means one vernier division is just a tiny bit shorter. It's 0.9 millimeters long. The least count is just that tiny little difference between a main scale division, which is 1 millimeter, and a vernier scale division, which is 0.9 millimeters. And what's that difference? Exactly 0.1 millimeters. Simple, right?
Now, taking a reading is super easy once you know the formula. First, you find the main scale reading. That's the mark just to the left of the vernier 0. In our example here, that's 2.1 centimeters. Easy. Next, you have to play detective and find the vernier coincidence. That's the one single line on the vernier scale that lines up perfectly with a line on the main scale above it. Here, it's the 6th line. So the total reading is just the main scale reading plus the vernier coincidence times the least count. So that's 2.1 centimeters plus 6 times 0.01 centimeters, which gives us our final precise reading of 2.16 centimeters.
All right, the vernier is great, but what if we need to measure something even smaller? Something like the thickness of a single sheet of paper or the diameter of a really thin wire. For that, we need to bring out the big guns. The micrometer screw gauge.
And here it is. The object you're measuring goes right here between the anvil and the spindle. You turn the thimble to close them. Now, listen up, this is absolutely critical. You must always use the ratchet at the end. That's the little part that makes a clicking sound to do the final tightening. If you just crank the main thimble, you'll use too much force. You could damage the delicate screw inside, or even worse, crush the object you're trying to measure. So always use the ratchet.
The micrometer gets its amazing precision from its screw. The pitch is just how far the spindle moves forward when you turn the thimble one full 360-degree circle. For most micrometers, that's half a millimeter. Then you have the circular scale on the thimble, usually divided into 50 parts. The least count is simply the pitch divided by those divisions. So 0.5 millimeters divided by 50, and there you go. That's how we get that incredible precision of 0.01 millimeters.
Okay, this is a very important point with micrometers. You have to check for zero error. Before you even measure anything, close the spindle completely using the ratchet. Now look, if the 0 mark on the thimble is below the main line, you have a positive error, and you need to subtract this error from your final reading. If the 0 is above the main line, that's a negative error, which you must add to your final reading. Always check this first.
Reading in micrometer is also a two-part process. First, get your sleeve reading. We can see 1, 2, 3 full millimeters,
But wait, look closely. That little half-millimeter mark below the line is also visible. This is crucial. So our sleeve reading is 3.5 millimeters. Next, find the thimble reading. Just see which line on the thimble lines up with that horizontal datum line. Here, it's the 28th mark, which means 0.28 millimeters. To get the final answer, you just add them up. 3.5 plus 0.28 gives us 3.78 millimeters.
All right, on to our final tool for today. This one is a bit more of a specialist. We pull out the spherometer when we need to measure the curvature of a surface, like a lens for your glasses or a curved mirror.
The spherometer works with these three fixed legs that form a perfect triangle. The central screw, which moves up and down, is basically a micrometer. By measuring the tiny height difference between the outer leg sitting on a surface and where the central leg touches, we can actually figure out the radius of that curve. Pretty clever, huh?
To find that radius of curvature, which we call r, we use this formula right here. First, you need L, which is the average distance between any two of the outer legs. Then you measure h. That's the vertical height difference you found with the central screw. Once you have those two numbers, you just plug them into the formula, do the math, and you can calculate r. Okay, so knowing how to use the tools is only half the story. Let's talk about how to avoid the common mistakes, the little traps that can ruin your otherwise perfect measurement.
The very first step to avoiding errors is just choosing the right tool for the job. I mean, you wouldn't use a super precise micrometer to measure the depth of a big beaker. A vernier is perfect for that. And you can't use a vernier to accurately measure the thickness of a sheet of paper. That's a job for the micrometer. This table is your guide. It helps you match the right instrument to its ideal application.
And here they are, the three biggest enemies of a good reading. Number 1, parallax error. This happens when you look at the scale from an angle. The fix is simple. Always look straight down, directly perpendicular to the scale. Number 2, ignoring zero error. We talked about this, right? Never just assume the tool starts perfectly at 0. Always check and always correct for it. And number 3, unit mismatch. Oh, this is a common one. Don't mix up your centimeters and millimeters in the same calculation. Always convert everything to one standard unit before you do the math.
So the main point is this. These amazing tools are only as precise as the person using them. Precision is a discipline. It means you have to be careful, you have to pay attention to detail, and you need a consistent method every single time. And I'm going to say it one last time because it is that important. Always, always check your zero error. Mastering these instruments is a huge step forward in your AL journey. So to help you keep mastering all your subjects, here are a couple of things you can do next.
If you found this lesson useful, and if it helped you understand things a bit better, please do us a small favor and subscribe to our channel, Study Hub Sri Lanka. And don't forget to click that little bell icon next to it so you get a notification every single time we post a new lesson.
Thank you so much for joining me today. Keep up the hard work and keep practicing with these instruments. In our next physics session, we're going to continue with Unit 1, looking at tools like the traveling microscope, and then we'll dive into the world of scalars and vectors. We'll meet again very soon with another lesson for your science subjects. Good luck with your studies.
वीडियो බලලා ඉවර වෙලා අපගේ YouTube channel එක subscribe කරලා වීඩියෝ එක like කරලා comment එකකුත් දාගෙන යන්න.